Good day, good people. To this video, I'll be diving into exact ODE. So in exact, the only thing that you need to know, you have to know how to prove exact. It is the most important step. Then after that, you need to know how to find the method of solution. Then from there, you also have to know how to write it in an implicit solution. Right. So now, first thing first, I need to make sure that del m over del y is equals to del n over del x, right? So now, with that being said, that means now this is this, and then this is this, right? I'll try by all means to teach you guys with the method or with the knowledge of a student to a student, right? I won't make it hard for you. I'll make it so simple that you will understand it, right? Using easy method. Now we are going to derive this partially. We're going to partially derive this. Mind you that here is del m over del y, right? So del m over del y. So now that means we're going to derive this respecting only y. I know it's very bad to be ignored, but then we have to ignore x. We don't have choice. Now del m over del y is equals to, we have to derive this respecting only y. So now that means 2 will come this side. We did this to 12. So now that means we'll have 2y multiplied by 3x squared plus 2x, right? Because here now we took this exponent y that was here minus 1. That means now there is nothing here, right? So we have 6x squared plus 2x. This is the derivative of this partially, right? So now let's go to this side whereby we have to deal with del n over del x, right? So now let us derive this, right? So now it's 2x cubed y plus x squared, right? So now here we have to derive focusing on x, because now at least x is having someone who cares about it. Now we have to do it's 6x to the power 2, because it's 3 minus 1, 3 this side, then y plus, here I forgot y, you see, I forgot y. So now plus 2x, because now this one it's been derived. Sorry about forgetting y here. I forgot this y here. So now it's proper. So now we have found that del m over del y is equals to del n over del x. This is equals to the function. So this is equals to the function. So that means this one is exact, right? Exactly, right? Now we are done proving the exactness, right? So now we have to go to the method of solution, right? Mostly when they are asking about this question, they will ask you to find the function f of xy such that this one del f is equals to del f over del x is equals to mxy, right? And del f over del x is equals to nxy. Now del y, right? When we are now assigning them, we focus on this, right? So it will say del f over del y, ne? To be this side, right? To be the one that is having nxy. Then it will also say del f over del x to the one that is having this, right? As I promised, I will teach you in a knowledge of a student to make sure that you cram it the way I used to cram it. You grasp it the way I used to grasp it. You will never go wrong, right? Now that means it's del f over del x is equals to mxy is 3x squared y squared plus 2xy, right? And del f over del y is equals to 2x cubed plus x squared, right? So now with that, we are given two equations, right? So now here, at least the only thing I love about maths, they also give you options to choose which one is it integratable easily, right? They're not fighting. They're saying you choose which one is it between this and this. You choose the one that is integratable easily, right? They said you have to choose. So what we have to do now, we said f of xy is equals to, you can choose this. I love this. I don't know why, but I love this, right? So now let us choose it. So it's 3. Actually, let us just write this first. then right, then we're going to integrate this, right, with respect to x. We're going to integrate this with respect to x. Then that means it's going to be equals to what? 3x squared y squared plus 2xy dx. Right? So now the integration of this, we have to find the integration of this, right? But the constant of this part, we have to write it in a qy form, right? The constant, we have to write the constant instead of writing c. Instead of writing c, we have to say it's qy. Why? Because now we are deriving with respect to x. Then at least we have to feel pity for y, right? We have to feel pity for y and just say plus y or plus qy, right? So now we're gonna integrate this. So what is the integration of 3x squared y squared with respect to x? So that means it will be 3x to the power 3 divided by 3, right? Then y squared, then plus 2x to the power 2 divided by 2, then y, then plus qy, right? This is easy. This is easy. Then from there, this and this cancel, this and this cancel, right? And I hope you understand. I hope you are getting this drift. I hope you now understand that here, when we say x squared, it's because when you're integrating, you will take this and say 1 plus 1 divided by 1 plus 1, right? We did that in grade 12, those who did technical mathematics, right? So now, let's now come this side. It's f of x, y is equals to x cube y squared plus x squared y plus qy plus qy, right? So now what is it that we have to do? We have to try to find this qy, right? We have to try to also squeeze this in, because there is nothing that cannot be used. We need to be squeezing them in like nobody's business. Now here we have to derive this with respect to y. We have to derive all of this, everything here with respect to y, right? We don't always focus on x here. You see, when we are dealing with exactness is fairness. There is now no one who's not going to be used here. We have to derive, we have to integrate with respect to x and also include qy in the constant step. The following step, we have to derive with respect to qy or with respect to y, right? So now here we're going to say del f, because we are respecting y, we have to say del y, right? It's equals to, now here we have to derive using y. So how is it going to be? It's going to be 2y x cube, right? It's going to be 2y x cube, right? Hey, I forgot y here. All right, it's going to be 2y x cube, right? Now, plus, what is the derivative of y? It's 1. So it's going to be xy. The derivative of y is going to be 1, right? Then plus q prime y. So we're just showing that actually it is derived, right? So now, before you can do anything in this step, that's when you will know I'm doing them correctly, right? In this step, that's when you know I'm doing it correctly, because something must cancel out, right? Let us check this now. Didn't we come across something like this? Del f over del y. I didn't do it purposely. I was just integrating this, deriving this with respect to y. I was just deriving this with respect to y. I did like this because the rule says we have to derive this with respect to y. This one, this part, right? So after doing that, I happen to have something that is exactly, looking like this. And there is nothing I can do. This is mathematics. There is nothing I can do. Mathematics is saying you should do what needs to be done, right? And in maths, you need to teach yourself to learn, not to unlearn, right? So now here we have to substitute this here. It will be 2x cubed yx squared is equals to 2yx cubed plus x squared plus x squared, right? Plus qy, right? Another thing that you should know, always you should know, in exact, if in this step nothing cancel each other, that means you did it very wrong. After deriving, something must cancel something. If it doesn't cancel, that means you did it very wrong, my friend. Now see, 2x cubed y plus x squared is equals to 2x cubed y plus x squared plus q prime y. Bingo. Then check this and this. It's the same thing. It's the same thing, right? You can just write it to to show them that you don't want to assume, you want to subtract them. You want to subtract them. Is equals to q prime y. Right? So now this subtract this will subtract this, then it's 0 is equals to q prime y. Right? Then from there, since we are looking, do you know that now we are looking for this part? This is what is asked. Find f of x and y. Right? So now in the first step, we had f of xy is equals to x cubed y squared plus x squared y plus qy. Right? So at least let us find qy. How do we find qy? You know from high school, when you want to find the integral, we derive, and then from the derivative we go to integration. From integration we go to derivative. So what can make us have this qy exactly as it is? What is it that can make that happen? It's when we apply integration. Right? We're gonna integrate this in terms of y, integrate this in terms of y. Then here we'll just get 0 is equals to, this one will go back to be qy. Humbled. Right? So now it's qy at least plus c. Right? So now let's continue. Let us write our final answer, which is f of x y is equals to this x cubed plus y squared. It's x squared y plus q y, which is 0. We found that it's 0. So we can just say plus c, and then it's x cubed. So is this part, then plus x y, then from there say it's 0. Right? So that means it can just be x y squared plus x squared y. At least let us include c, then that is it. So they can also ask you to say, write down the implicit solution of differential equation in the form of f of x y is equals to c. Right? So you just have to say f of xy is this again. It's just y squared. It's just y squared plus x squared y is equals to c. That is the only correct answer. So I hope you like it. Honestly speaking, I'm doing this because you guys are subscribing, you guys are liking. So I will keep on doing this kind of content if you guys keep on liking, sharing with your friends, sharing with your classmates, so that you can pass. Right? So see you on another one whereby I will be doing, I don't know whether step in function, whether Fourier series, whether calculus, I don't know, but for now, keep this and enjoy.